Okay, hi everyone, it's Um, Today I'm going to be going through question 4, the first one, the proof for y being equal to some amount. Um, but before that, I just want to go through the basics of compounding interest very quickly because it seems that a lot of people know how to use it and know when to use it, but they don't know why they're using it, right? So basically, if I have an amount of 100 Rand and I am compounding it at 10% per annum for 5 years, the expression, as you see on the top, is exactly the same as what I've written underneath it. So it's the same as, because of the power rule, 1 plus 10% being the base, repeated 5 times, right? And if I expand each one in order, you'll get to the exact same answer as if I were to do it on a calculator, which is 161.51, no, well, 5 cents, and a 1 after that. So that's basically what we're doing. So this 1 plus 10% to whatever power it is, it's called the compounding factor. Um, this you guys will deal with a bit later, namely in second semester. But for now, it's good that you guys know what it is, because this compounding factor is basically if you multiply by a positive interest rate, well, obviously positive, by an interest rate, then you're gonna add interest onto your amount that you had initially, and if you divide by that interest rate, you are going to remove interest, and that's what we call discounting. And that's the problem that I see with some of the attempts at this question, is that a lot of people know how to express each annuity, but um, you guys forgot about discounting it, and I'll explain why we have to discount it in a minute. So I'm just going to go through the question quickly. It's a young couple decides to buy a house for 1,450,000 Rand. They plan on paying 15% of the purchase price immediately as a deposit. The remaining balance of the purchase price will be financed by a bank loan that will be repaid over a period of 20 years. They agree to repay the bank as follows. So then they say for the first 10 years, they will pay an amount Y at the end of each month, right? So immediately in your head, you should be thinking that there's 12 amounts of Y that's going to be paid for the first 10 years. For the remaining 10 years, they will pay an amount of 3Y at the end of each quarter. Now, this is where it gets tricky, because 3Y each quarter means that there's 4 payments of 3Y occurring. From some of the workings that I've seen, you guys kind of forgot about the 4 multiplied by 3Y and the 12 multiplied by Y for annuity 2 and annuity 1 respectively. So they say the interest rate is constant at 10.2% per year, and they want us to show that Y is equal to 11,718 Rand, rounded to the nearest Rand. So first off, what I did was I took the loan amount, 1.45 million, and they say a deposit of 15% is paid at outset. So I did it the fancy way, if you can call it that, where I just put in a bracket of 1 minus 15% and you get that amount. You could also just multiply 1,450,000 Rand by 15% and then take 1.45 million and subtract the answer you'll get the same thing. It's just quicker to do it that way. Now we do our conversions, because when we saw that the annuities were paid at different periods, like monthly and quarterly, we know that we have to do some form of conversion. So we're given I is equal to 10.2%. I use the formulas, the relationship between them. You guys have this in your slides as well. 1 plus 10.2% is equal to, and then 1 plus 12, I12 over 12 to the power of 12, and same with the 4. So that'll give us the nominal interest rate monthly and quarterly. The monthly rate comes to 9.75% and the quarterly rate comes to 9.83%. Now here's our timeline, and this is the important part that you guys seem to forget, and I would suggest that you guys always draw a timeline of whatever question you guys are doing. So we have that at time 0 we paid 15% and annuity 1 starts, right? At time 10 is when the finance options change. So now we stop paying annuity 1 and we start paying annuity 2. And at time 20, annuity 2 ends, right? Now, for us to discount each one, you'll see that annuity 1, when you discount it, when you do the formula, it'll take you back to time 0, right? Because that the annuity formula groups all the payments that you have made, and it basically removes interest from it and gives you that value at the time the annuity starts, not always at the time of 0. So in our case, annuity 1 started at 0, so that's fine, but annuity 2 starts at time 10. So we'll have that all the payments made for annuity 2 up until time 20 will be discounted to time 10, but we don't want the amount at time 10. We're looking for the amount at time 0. We want everything to be at time 0, so this is why we discount again for another 10 years. So following on that, this is what the model looks like. So I have 1, 2, 3, 2, 500 is equal to 12y, and then my annuity formula, and I used I12 in the denominator, and then I added it with 4 times the amount of 3y, and then again annuity formula with my quarterly rate. Now you'll see in red, it's my compounding factor to a negative exponent. It's exactly the same as just dividing my second term by a compounding factor of 1 plus 10.2%, right? So we did that for 10 years, so I discounted it. And here's some notes. It'll say that the PV gives you the PV at the time the annuity starts. The second term does not start at time 0, it starts at time 10. We have to discount it for 10 years. That's what that red compounding factor to the negative exponent is for. And then when we solve for y, we'll just find that y is more or less 11718. That's after rounding. So I hope this clears up everything for you guys. I know that the video is out after the assignment has been handed in, and that's because I don't want to give you guys like the answer to it or anything, but I do want you guys to understand what we're doing, because you're going to be doing a lot of this in next semester and in next year if you do have BAVIA next year. So I hope you guys enjoyed. I hope this explained everything nicely to you guys for this question, and stay safe.